Okay, and the recording started. Hi, everyone, and welcome to the 84th community call. My name is Nima Uversky, and I will be your host for today. I'm a Dapr community manager. Today, we'll go ahead and be covering a lot of cool things today. So we'll have a 1.11 release. We'll just walk through that. We just released that. So we've got a lot of cool features and stuff that we want to talk to everyone about. And then we're going to go ahead and dive into a user scenario from OceanBox and then look at a demo for simplifying identity access management with Kubernetes using Keycloak and Dapr. And then we're going to round it out with a community show and tell and some open discussion. So first, let's kick it off with the 1.11 release. So first of all, we have gone ahead and officially released 1.11, which is super exciting. It's been a lot of effort. Huge thanks to everyone who put in so much work to make this release possible. This release is huge. We have a bunch of really cool things happening. We've released a few new APIs. So we had the configuration API go stable. We have service invocation for non-Dapr endpoints. New features for Dapr workflow, a brand new cryptography API in preview, and actor state TTL. We also released a bunch of new components, had a few go stable, and a lot of new component improvements. And we rounded it out, of course, with a lot of runtime improvements to the runtime in the CLI with app health checks, multi-app run improvements, metric support, et cetera. I'm not going to walk through everything here, but we have the blog release up here if you want to read more in detail. But just want to give a quick shout out to the team for such a huge release. Okay, so next we're going to go ahead and switch gears and dive into a customer case for OceanBox. Jonas, do you want to go ahead and give a quick intro and take it away?
Yes, thank you. So let me just share my screen. Okay, share screen. Right, can everybody see my screen now?
I want to, before you start, it looks like I just looked at chat. It seemed like people were having issues with seeing the screen. Folks,
I think it's okay now.
It is perfect. So you guys can see Jonas's screen. Awesome. Okay, Jonas, you're good to go.
All right, super. All right, so my name is Jonas Juselius, and I'm the CTO of a company called OceanBox. And before I tell more about that, I'll just give a little brief introduction to my background and to OceanBox. My background is originally in quantum mechanics, but about 10 years ago, I transitioned over to computational oceanography and worked on ecological consequences of oil spills and simulating oil and stuff like that. And approximately a year ago, me and some colleagues got sort of frustrated about the state of affairs in this area and decided to start our own company and do something about it. So in April last year, we started OceanBox. And OceanBox is a company which provides detailed, high-resolution oceanographic forecasts and simulations as a software as a service, easy to use. And for those of you who aren't sort of familiar with what this is at all, what we do is that we simulate how the ocean and the seas are moving, their properties like temperature and salinity, oxygen, and so on, and currents. And this is pretty much the same thing as what the Met Office does for the weather. So it's very similar mathematics behind it. You set up a model, you discretize, and you solve some big equations on big computers. And these type of simulations are really important because if you sort of try to measure what is happening in the sea, it's all fine, but I will only tell you what happened in a single point in the past. So if you want to know something more general about what is happening in the sea at large, and where things will end up, if you drop something into the sea, you're going to need to do simulations, and that's what OceanBox is doing. We're of course not alone in this field, so we have of course a lot of other actors doing simulations. But usually, typically, what they do is that they use very traditional methods, and the simulations they run are quite coarse. So here on your left, you can see the Norwegian Met Office's official available model for a particular little piece of ocean. And you can just see this big red square, or a couple of them. And that's like 1 pixel. That's the resolution of the model. And it's quite obvious that if you want to do any kind of sort of trajectory on this model, it will be very, very coarse. And a lot of places where there's sea, there is actually nothing, no sea even in the model. On the other hand, on your right-hand side, you see a typical model that we use in OceanBox, where we have these very fine-grained triangular grids. And I'll come back to this in a moment. I'll show you a demo how it looks. So also doing high resolution oceanography isn't a new thing. People have been doing this for years and years and years. But basically how it works in the real world is that if you want something that the Met Office isn't giving you, if you want a finer resolution model, you have to contact some kind of consultancy near you, ask them to set up a project, and you have to typically wait 3 to 6 months and pay a lot of money to get a PDF report on your desk. And that's not really useful if you want to, if you're going out to sea tomorrow to do some kind of operation. So what we have done is that we have tried to make this as simple as possible and self-service. So you can just go into a web service, set up some simulations, click, wait a few hours, and get realistic predictions for a much, much smaller amount of money. So that's basically the idea that we have. So let me just do a little demo so this becomes a bit clearer what we're doing. So currently we are working in Norway, and we're mostly working with aquaculture, because aquaculture is a huge thing in Norway. They have it's a $20 billion annual sort of industry, and pretty much all the values they have are in the sea, at the mercy of the sea. So that's initially where we are putting our focus. And what you see here in the map is that we have some what we like model areas where we have set up models, and then we can select one of those. I will select one from Tromsø, because that's where I'm located. That's 400 kilometers north of the polar circle, which means that currently we are having 24 hours of sunlight. The downside is, of course, that in the winter we have 24 hours of no sunlight. So, but here's a picture of Tromsø, and just to show you a little bit about the discretization, how we discretize the sea. Here's the complete model, and as we zoom in, we can start to see how the sea is triangulated. And we can go down to pretty fine scales and see. This is still a fairly coarse model. We also run much higher resolution models for smaller areas, but this is sort of a typical standard model that we are operating. Now, each triangle in this model is corresponding approximately to a pixel, if you would think like a photo. So that's where we have a set of parameters like temperature, salinity, currents, and so on. And we can look at them. So let me go first to a spot here and jump to April, and I'll show you a little bit. So I'll just turn on the salinity. This is the salt content of the sea. And you can see that there is blue where there's very little salt, and the more yellow it gets, the more salt there is in the sea. The reason there is this blue is that there's a huge river coming out here. And as the snow starts melting, this will get more and more. And you can see how things go. And we can even step hour by hour if we like, although it's perhaps not so super interesting. We can also look at, for example, the absolute current. So red means strong current, blue means weaker current. And we can zoom in a little bit here on the timeline, and I'll find a good spot and see if we can find where we have. So we got some pretty strong currents here around Tromsø. I can turn this off, and we can also have like these stream visualizations of the currents. And this allows oceanographers to gain, and also customers to gain better understanding of what's going on in the sea. And we'll step forward and see how the conditions change. Let's see if we can get the nice view somewhere. We have really good. So this is sort of the basic oceanography that we have. On top of this, we can also run simulations. So let me just show you how we can do these simulations. I'm going to just run a simple transport, which basically means throwing stuff into the sea, something that sort of is neutrally buoyant, and just let it float. And I can just pick some point. We can put it there. We can make it a little bit larger. I'll give it a name. Just call it Dapr. Run it for 3 days. Doesn't take too long. Yeah, just do a low resolution thing. And as I press now submit, I get a little blob here saying running. So what now happened is that it defined, the system defined a simulation with some parameters and sent it to our supercomputer in the basement, where it's now running with 128 cores. And it's going to take about 5 minutes. So we'll see if we can that will finish. While waiting for it, I can just show you what it will do. Let's see, zoom out. I'll just find here a couple of other. Just take this one. So here we have now a release point in that location, and then we can just step the time and see how these particles start moving. I can turn on the heat map so we can see it a little better. I will jump forward in time and see how things are moving. And then there's a lot of other things we can do. And we can simulate various types of parasites and viruses and chemicals and so on and so on. So this is just the simplest sort of thing you can do with this. So that's sort of should give a general idea of what type of stuff we're doing. Now, this is the system we have is running on pretty much sort of quite standard technology. But what kind of makes us a little bit special is that we pretty much do all our coding in a language called F#. And I don't know if you are familiar with F#. F# is a language from Microsoft. It's originally running on the .NET platform, which is really good because that means that we can leverage all of this ASP.NET Core and all of these things directly. It's a functional first, object-oriented, super practical language to use. What is nice about F# is that there's a compiler called Fable, and Fable allows you to write F# and compile it or transpile it to JavaScript, which means that we can write all of our web interfaces, all of our web applications in F#. So what I just showed you was completely 100% written in F#. Fable also allows you to target Python these days. So you can, if you need to do work with Python, I want to use a language with a strong type system, then you can integrate easily with Python. It also compiles to Rust, and very soon it will compile to Go. So it's a very useful language. And then we sort of deploy pretty much everything on Kubernetes, as most people do these days. And we use Dapr as glue, sort of to glue all these services together. Because, of course, we're going to have to do some sort of, I wouldn't call them exactly microservices, but they are sort of at least one domain per service. I apologize for this graph. I didn't have time to do anything very quickly, so I just drew it on my remarkable pad. So So this is sort of an overview of the architecture of the core of the system. We have two systems. One is a standard Kubernetes cluster. The other one is a HPC system, which is based, it's a system from Lenovo. It's based on AMD EPYC, HDR InfiniBand, for those who are familiar with those things. So it's super, super high latency networks in order to run these oceanography calculations, because these calculations are kind of hard. They typically run them on 1,000 to 2,000 cores, and they run for, if we want to simulate the year, it's typically 3 to 4 weeks on 1,000, 2,000 cores, a little bit depending on the model. Each model is producing huge amounts of data, so we somewhere between 20 and 50 terabytes per year. And this means that that data, we can't really just copy it around because we have a lot of data. So we're actually running part of the system is running directly on the HPC system. It has the internal name sorcerer. It sources data to the client. Everything else is running on Kubernetes in a standard Kubernetes cluster. So the user will connect to the service called Atlantis. That's the internal name for the web interface, and interact with that. Atlantis will forward it to a service called Archmaster, which contains all the available data archives, everything, all the metadata for the archives. The client will then know what archives to access, and then it can fetch the data from the sorcerer. And sort of that's all pretty okay. User information is stored in a service called petimeter, which means nitpick in Norwegian. And that's actually a Dapr actor. So we just keep all the user state in an actor, which is really quite convenient. And then we have a service called Hipster for running and managing calculations, and that's also built around an actor. Hipster is an acronym, a little bit contrived, for HPC interface to Slurm type resource managers or something like that. So we needed to find a good name for it. So whenever you start the calculation, what will happen is that Atlantis service will connect to Hipster. Hipster will set up the inputs. It will send it over a REST API to the resource manager on the HPC cluster. It will probably get queued if there's a lot of calculations going for some time. So this might be start immediately or some hours or days later. Slurm will inform back over to RabbitMQ any change in state of the simulation. Hipster has a Dapr binding so that whenever there's something going on there, Hipster will get notified, update the actor state, and when anything that it thinks that the user should know about, it will publish an event back to RabbitMQ, and Atlantis is then subscribing to those events so that it can notify the user of state changes. So this is sort of roughly what we are doing. So we're using really sort of simple things with in Dapr. Nothing very, very advanced, but it's really sort of works nicely, I think, for us. So some lessons learned. When we started doing this and started piecing these things together, I've looked at sort of quite a few different things. I've looked at mass transit, end service bus, Rebus, Akka, Orleans, and then I found Dapr, and it ticked all the boxes because it was language agnostic. It had pretty much everything I needed, and it just seemed like a really nice design. So I immediately liked it and just discarded anything else I'd done and went for Dapr. A little bit down the road, I realized one thing, and that was that actors aren't currently namespaced at all. So all the actors, if you have an interface for an actor, it will just get completely intertwined with everything else and you can't really sort of, if you have different environments for staging and for production and review, they all start messing up with each other. And I had to think a little bit how to solve that problem. And the way we do it today is that we use Kubernetes V clusters. So for all the environments, except the production environment, are running in a V cluster with their own private little Dapr thing. And then everything works out really nicely. Another thing that we realized was that using Dapr and you have all these services around, it becomes kind of hard to sort of do hot reloading development in sort of the workflow that we're used to. And just as a little hint, Tilt, if you're not using Tilt, Tilt is a fantastic tool for that. And with Tilt, it will hot update containers in Kubernetes and restart the services there. And then we can run the JavaScript proxy Webpack Vite locally and just using port forwards to access the latest version of the service with all the Dapr goodness and everything in the clusters. That's a super nice way to do it. And we have a very, very rapid development cycle that way. Here's our team. We're a small company, still growing. Yeah, that's it. Questions?
Let's see. I don't see anything in chat, but we have some time if anyone wants to unmute to ask a few questions. Okay, sounds like we don't have any questions.
I'll ask a question. This is super cool, by the way, Jonas. I think this is an amazing example of how you evaluated and took on Dapr. I like the way that you sort of consider this with other alternatives. So it sounds like it's pub sub is the main thing that you use along with sort of the bindings. Is that the main benefit that you got from it, as long as, and the actors? Is that really the driving factor for you?
Yeah. So partly because I used to be pretty happy with doing a bit of Smalltalk programming and stuff like an Erlang. I dig actors, so whenever I can plug in an actor, I'm happy. So, but yeah, the bindings are really, really nice, especially when you have completely disparate systems and you can just connect to the RabbitMQ and send in stuff and things will automatically happen. That's really beautiful.
Awesome.
And maybe you could come back and show us a little demo sometime of how you use Tilt. I think that'd be great to show us in future, just because I think that'd be a great way.
Oh yeah. Actually, I did like Tilt is super easy to set up and use. But I probably spent a week learning how to really get it down. So I'd be happy to do a demo of that and share the recipes there, because there's quite a lot of dark little corners that one needs to know about.
All right, we'll take it up.
Hey, Jonas, I have one more question. What's your telemetry stack, and are you looking at metrics and tracing from Dapr?
Currently, I haven't had time. Like we've been focused on squeezing out new features and not so much worrying about telemetry. But that's coming up now. So, but we're using Jaeger currently.
Okay, for tracing.
Yeah. And but I can't. I've skimmed through a little bit of it, but documentation and tracing.
Yeah, you're going in without observability. That's the YOLO approach. I appreciate that.
Yeah. So currently we're like four full-time people who are developing on this, and we are just squeezing to get. We have like 3 customers. We have quite a lot of demo users from industry, but we have 3 customers. So it's not like we sort it out, but this is going to be super critical pretty soon.
Yeah, I imagine. Okay, thank you.
Yeah.
Perfect. So let's go ahead and, well, Jonas, thank you so much for sharing your scenario with us. But we want to go ahead and move on just because we want to be conscious of time here. So we do have another speaker. Let me go ahead and grab the screen actually. Okay. Can you guys see my screen?
No.
Not yet.
Oh my goodness. Well, I guess it's not important. I can just go ahead and present our next speaker. So we have our next speaker is going to be Abhishek. Abhishek, do you want to go ahead and do a quick intro for yourself and share your screen?
Sure. First of all, can everyone see my screen?
Yep, we can see it.
That's great. So, hi everyone, my name is Abhishek Koserwal. I work at Red Hat. I'm a principal software engineer. So my area of expertise is around authentication and IAM domain. So I'm doing a lot of work in that area, and I have done a lot of writing work around Keycloak and how you can secure your application. So in today's presentation, we will see how Dapr makes it easier for you to secure your microservices backend API on Kubernetes, and without very less configuration and without worrying about putting that security auth libraries in your main code base. So let me start the presentation. So I'm using Dapr, the latest version, and 1.11, and Dapr middleware, HTTP middleware comes with three basically ways you can secure your application. So there are three components: OAuth2 authorization grant flow, OAuth2 client credential grant flow. Basically, they are part of the same OAuth hierarchy, and they are different ways to secure based on the flow type. And the third one is OpenID Connect. So we will review all these three things and how you can secure your application and what is the difference basically in the flow. So let's look into it. So I'm using Keycloak as my IAM solution, which is very open, dynamic, and provide a lot of authentication, authorization, configuration in a single window, and it's quite scalable. So I'm using Keycloak for securing all my application for this demo. Just give a short recap about Keycloak. Is there any question in the chat? Yeah, thanks for putting the Keycloak. So, once again, sorry. Yeah. So I can give a quick conceptual review of Keycloak. What basically through this slide deck, you can understand how Keycloak configuration is structured, how Keycloak has been configuration is maintained. So the main thing in Keycloak is a realm, which is basically a kind of way to organize your configuration in a metadata way. So you will have like a one realm that will maintain your all type of configuration. You can create multiple realms, and then you can set all the other configuration into it. It is recommended that not to use master realm, use a separate realm for managing your application, and use master realm for only administrative purposes. In your realm, you can create clients. So for that you want to secure, you can create a client configuration where you basically mention like what is my app details, like what is the URL, what type of protocol I want to use for securing my application, and other configurations. So through this, you basically maintain how you want to secure your application. And there are other features in your Keycloak, like you can do user federation. So you can do user federation through LDAP. You can use some customization, like you might have a user service, so you can do some customization in your Keycloak to add that as well as a source of users. You can bring users through other ways like identity provider, like you might be using some social plugin like GitHub, Facebook, or any other identity provider. And there are other features like you can use groups to maintain users in a topology. Then you can have roles. You can see events like when user login, when the admin logged in. So there are a lot of events that you can see. And then you can also do UI customizations. So we'll see one by one how the OAuth middlewares that we see supported by Dapr and how you can do the configuration in Keycloak. So we will first understand how the Dapr auth authorization grant flow works. So for securing your application with Dapr, all you need to do is you deploy your application in your Kubernetes environment, you configure the Dapr, and then you can configure the OAuth to middleware and set up some similar configuration for that respective application in the Keycloak. And that's all you need. And then you can just hit your regular endpoint invoke method in the Dapr to invoke your API, and Keycloak or the OAuth middleware will intercept that call and try to do the security. So for this, explaining the all three flows, I'm using a same Go Echo application, which is basically a simple API which accepts some request parameters and just send you the response. So we will try to understand how OAuth authorization grant flow works. So basically, the user here will send the same invoke method in the Dapr to invoke the Echo application. This call is intercepted by the Dapr sidecar, and it will do a redirection flow to Keycloak, where you will see on your browser that the Keycloak login page appears. Once you enter your user password, there will be a parameter in the request that is the redirect URI, whichever you configure, it will redirect back. So in this case, I have configured my Dapr application URI. So it will redirect me to the Dapr with basically the request I want to pass on. And one thing it will add is the access token, which would basically provide me the secure way to access my application, and it can deny any request without the authorization token there. And once the token is valid, then you get a response from your API. Now, which type of application are more suitable for this type of flow? Is there any question? Okay. So this particular type of flow is more suitable for where you need a consent from the user. Like if you are making a post request, so from some client and there is no browser or no way to user consent is provided, then this flow might not work for you, because in this flow you need the user to provide his or her credentials, and a browser is required. So often suitable for application where you can have that consent. Next, we can look into the OAuth variant, that is client credential grant flow. In this, I'm using the same example where user is sending the same request, but with Dapr, you can change the client credential like the middleware. So in this, you are able to access the API directly. What the Dapr will do is the sidecar will use a client end secret that is configured in your Keycloak and send a request to the Keycloak endpoint and retrieve an access token. So for every call, it will do the same process and inject an access token to your application. In this case, you won't see any redirection, and in this case, you can use non-browser clients that will work, and based on the access token, you will see the response. In this way, Dapr does not protect you on that endpoint. All it does is injecting the access token. So this particular way is more suitable for service to service invocation, or if you are running a client service that is going to communicate with other backend services. So in such way, it is more suitable. It won't secure exactly the endpoint that you are going to access. Now, the third flow is the OpenID connect flow. And in this flow, this is more suitable for your backend APIs, where you will send the same request and Dapr sidecar will only do the token verification. So if you are passing an access token in your request, Dapr sidecar will verify that access token, and if the token is valid, then it will pass the request to your API and you will get a response. So this is more like a lot of application follow this, where your front-end application is just sending a JOT token in the request body, sending it to your API, and API is just validating your token. So this is more popular and stateless way to deploy your architecture on a lot of stateful orchestration platform like Kubernetes, where your backend is just verifying the token and taking the decision. So I'm going through the demo now. This is the link where you will find all the configuration, and there is a written blog which it talks in detail how you can set up everything that I'm going to show. So for the demo purpose, I am running a local Kubernetes client cluster where I already installed the Dapr configuration through Dapr CLI, and also installed the Dapr dashboard. So you can see in the Dapr dashboard where you can see my 3 applications. This is same application with a different components. So in the component tabs, you can see the 3 components basically that I have configured. And how you glue this middleware with your application is through a pipeline configuration. So for example, if I go to pipeline OIDC, you can see my application name or the service name is here. For configuration, you can see it's very easy. For OAuth2, this is my YAML file for deploying the application. This is my OAuth2 configuration where I have added like client ID, client secret, the auth URL, token URL. And this URL is coming from the local Keycloak that I'm running. So I'm running a Keycloak where I have created a demo rel. And in the demo rel, I have created 3 clients for each for my application. So very secure password. So here's my client, and you can do client ID configuration, and you can provide your root URL and service URL here. So, and you can set up other parameters like you want client authentication, you want standard flow, you want other things. So you can do that configuration here. Now, same thing, you just have to copy paste here, and I'm running a ngok to just make that URL available to my Kubernetes. You can also deploy your Keycloak on the same instance, but for demo purpose, I'm assuming that my Keycloak is external to my Kubernetes instance. So that's why I'm using ngok. This is a public URL. So the Keycloak is now currently accessible to internet. And for in the OAuth2 configuration, you can do, and in the pipeline, you just have to mention like which type of OAuth middleware you are trying to set. And this is how we will configure this configuration. So let's try to access the API and see how Keycloak is going to help you secure. So as soon as I enter the URL, it have redirected me to the Keycloak login page for the demo rel. And I'm using a test user to log in. And you can see this application is now secured using Keycloak, and you can see the response, the query parameter that you are sending, and the injected access token. So this is the access token that you are sending as a authorization header. Now for the OAuth2 client credential flow, I have the same process. If we try to access this endpoint, in this flow, there was no redirection. You were able to just hit the API directly. All it does is basically injected the access token here. If you even do like, if I send this through a call request, it will also inject an access token here. So if I'm sending a request, Dapr sidecar is sending a request to Keycloak, getting the access token and injecting in the header. So this is more useful when you want to invoke some other API using this. And the last flow is OpenID Connect, where in the OpenID Connect, all you have to do is configure a client ID and the issuer. And JWKS URL is optional. Basically, it's the certificate that is used to verify your access token. So if I'm trying to access this API directly, you will get an unauthorized response from the Dapr OAuth2 middleware. And for accessing this, we need a token. So I'm basically sending a request to Keycloak's token endpoint using a client ID and a client credential. So I'm getting this token now. And using this token, you can basically access your API. So I'm exporting this token, and you can basically send a request. You can with this token as a header. So I'm currently passing something wrong. So it gave me now I'm passing the access token. Oops. It's not injecting it. Think what's wrong here. Okay. So one reason it could be wrong is because my client product configuration is wrong and my auth claim is not matching it. So let's first try to check what is my auth claim value here, because even if you are sending the token, the client configuration might be missing. So we can first try to see what's the auth claim here. So for this is the auth claim that needs to be matched here for your application. And if you are setting the same client, then it should match. Okay, the application is correct. It should match. It's more secured, and I think something is wrong with my configuration. That's why it's not working. But basically, that's how, like, if you have a configuration right, then it will basically provide you the response. I need to check. I was playing with my environment. So that's pretty much it. You will find all my configuration here and how you can set up your application with all these configurations. Any questions?
Yeah, one question for me. This is your own. Do you all at Red Hat maintain Keycloak mostly these days, or?
Yes, Keycloak is maintained by most of folks at Red Hat, and I think it's also accepted in the CNCF project. So I think they are also looking for outside contributors, and I think it's growing at a very good pace.
Yeah, from my perspective, at least, I've seen a lot of people using Dapr and Keycloak, or asking about how you can use Dapr and Keycloak. So seeing this is very timely because I've seen more of these asked recently. This is a pretty good overview right there, and maybe there's PRs that you can push into docs if you're so willing to make it easier to explain to people how to use Dapr and Keycloak.
Yeah, definitely.
I was just about to say that we have a great section on integration with other services, and if we could have something in the Dapr docs that points to anything that you have, or write some docs inside Dapr for this, you'd have a lot greater visibility of people understanding and using it. So it would be great to see something if you have a chance to do that.
Okay, thank you.
Perfect. Okay, so we'll go ahead and move to our next topic, which will just be a show and tell from the community. So Marc, do you want to go ahead and share your screen, or do you want me to share?
Yeah, I'll start sharing right now.
Awesome.
All right, so I'll do a quick run through of all of the community generated content like blog posts and presentations people did, webinars, and we'll start with the blog post. And again, 2 articles by Martino Bourdain about servicification in PubSub and output bindings are both our LinkedIn articles. Then there's an introductory Dapr article by Sebastian Kulinski. 2 articles by Thomas Akini. I hope I pronounced that name correct. Again, also some introduction articles there on Medium. Actually 3 articles. And the final article is one on Dev 2 by Sebastian Wessel about the need for a new backend framework, which is an interesting article because it is really a brand new backend framework. And I still have to read all the details. It's written in TypeScript, and on the one hand, it uses Dapr, but it also overlaps with Dapr in many ways. So I'm very curious about your opinion. So yeah, if you're interested in Dapr-like frameworks, definitely give this article a read. Let's move on to the stuff that happened on Discord. So Bernd was sharing a very nice thing to enhance your prompts, your terminal with the Dapr version you're currently running. Yeah, these prompt enhancers, these visualizers are available for many different terminals and operating systems. So yeah, I'll definitely start looking into one for my Porsche as well, because I use a lot of PowerShell. But this one is nice for GSH. Definitely useful if you either do a lot of testing with different Dapr versions, so you can nicely see the current Dapr version you're running. Then let's move on to messages on Twitter. So Kendall and also Marc gave a session at Open Source Summit about Dapr workflow, and which is now online. So I also include the link here so you can check it out on YouTube. Then I gave a webinar also with Kendall again about Dapr workflow. It's really a hot topic these days. That's also on YouTube. Then there was a meetup in the Netherlands, and there Jorrit gave a session also about Dapr, like an introductory version. And Jorrit is actually like a former colleague of mine, so I didn't actually know that he was doing stuff with Dapr, so that's nice to see. Then Jeroen, also in this call, was interviewed by Changelog here, so I include the link here so you can listen to the podcast. Then Shubham, one of our Dapr contributors, was doing a session on Dapr during Dev Days. And then we have another session at a meetup called Bit Summit. That is still to come. I think it's next week. I think it's in Hamburg, Germany, by Jabbar Asadi. And that was the round of content. So if you want to be featured next time in this community show and tell, definitely please join the Dapr Discord and mention all of the stuff you're doing in the show and tell channel there. Thank you.
Awesome. Thank you so much, Marc, for finding all these things. This is so cool to see all this going on in the community. Okay, so we are close to time here. I want to see if we have any topics for discussions or Q&A, or basically on anything we've talked about. It could be on any of the demos or any of the cool projects Marc shared. Maybe let's go to chat. Cool. I'm not seeing much in chat. I see Jeroen is super excited to see D2 IQ showing love to Dapr, but outside of that, I think yeah. Okay, so it looks like we are all good for today. In that case, we can go ahead and end the community call for today. Thanks everyone for joining.
Thank you. Bye-bye.
Thanks. Bye.
Thank you.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye.